Hi guys, a little bit different video today. So some of you asked me to explain the voltage drop, or so-called Vdroop, and all the different load line calibration settings on the Z390 Dark. So I will do that today. So Vdroop as a term means the overall voltage drop of a CPU, or even on a graphics card GPU, when the particular part goes under load. So it's very normal for any CPU to have a huge voltage drop on the set Vcore value when the amount of current that it draws starts to go up. So and for overclocking to remain stable in all conditions, we have to compensate that huge voltage drop to have the actual voltage value as close to the set value as possible, or even a little bit over the set value to remain stable. So that's the optimal case, or the optimal situation, and that's why we use the so-called load line calibration in the motherboard BIOS. So like easy explanation for load line calibration is voltage compensation for load scenarios on the CPUs, and this is exactly the same on graphics cards as well. And when it comes to testing these different levels and just measuring voltage accurately in general, with many motherboard models out there, and this applies to Z390 Dark as well, there aren't software that can measure the actual Vcore value accurately with some motherboard models, and this particular board model is one of those. So at least for me, when it comes to CPU-Z, the value is always all over the place, and it's nowhere near the accurate like true value. And the well, on this board you can easily measure the actual Vcore value from the Pro-bit connectors that are on the top side of the board. It's not so easy to see on camera, but they are over there. So the Vcore pin is the first one from the left, on the left connector. So there are two connectors, and every second pin on those connectors is a ground pin. The pins are labeled on the board's PCB next to those connectors, but it's now impossible to show that on camera, and you can find the information of the different pins from TIN's original guide at xdevs.com. But I'm just now measuring the accurate voltage value with an Xtech multimeter. So it's measuring 0.971 volts, and in the BIOS it's reading 0.973 volts. So it's pretty much spot on, and this is with the this is with everything at stock. So this is pretty much the VID of my arrow stepping 9900K. So VID, and on this board, when I told that the CPU-Z just reads some kind of voltage value, so it tries to read the CPU's VID, but it doesn't even do that accurately. So VID stands for voltage identification digital. So it is the initial voltage that the CPU requests from the motherboard when it's turned on for the first time. So yeah, you could say in easy words that every CPU out there has a different stock voltage. So this is kind of part of the whole silicon lottery thing, and it's exactly the same on graphics cards as well. So different GPUs have different VID. So on graphics card, this is the so-called ASIC quality, which you can read from GPU-Z. High percentage ASIC quality means that that particular GPU has a very low VID value, so it has a very low stock voltage value. And low percentage means that it has a higher VID value, so it has a higher voltage or higher stock voltage than many GPUs of that particular model. So and then it's just for the end user to determine what kind of CPU or GPU is the best one for overclocking purposes in the end. Some people say that low VID parts are better because they draw a bit more current at set Vcore values than high VID parts, but they overclock better when they have adequate cooling. So for example, they overclock better on sub-zero temperatures than high VID parts, but they often might run worse on air or water cooling because they run so hot that it's very hard to cool them, or it's very hard to maintain them at very suitable temperatures. But that varies on different generations, and it's pretty much for the end user to solve that question mark. But yeah, in any case, for this testing scenario, I will be using this X-Tech 505 multimeter to test all the different levels for you. So pretty much the whole rig is the same as in many of my videos. So EVGA Z390 Dark, arrow stepping 9900K, 2 sticks of 8GB Samsung BDI A2 PCB, Galaxy 710 GT for graphics, or pretty much for monitor signal, and then the Superflow 2000 watt power supply and custom water cooling loop on the CPU. So let's move on to the BIOS now and see what kind of settings we are going to use. So as you can see now, everything is pretty much at stock. So for this testing purpose, we will be using my daily 5.2 profile, which you can find when you just move one step left from the OC tab to the extras, press down, go to OC profiles and press enter. Then you get the 4 main profiles for this board. So choose the first one, which is my 5.2 GHz 4300 Samsung BDI daily profile, and we will drop the clock to 5 GHz just to remain stable in all or at all low line levels. I will just take the AVX ratio offset off, 4.5 on the cache, and I will first test I will put the Vcore Vdroop option to auto to see what is the auto result if we just didn't use anything there. And I'm just using Vcore at override mode, so I'm not using adaptive because I pretty much use override always, even for my daily use. IO and SA can be like that. I will drop the memory to 4133 just to be certain, and 1.43 volts for the memory. So let's see what the actual value will be in the operating system now with load line at auto. So right now I just arrived in the OS at the set speed that we put in the BIOS, and when I talked about software measurement on the Z390 Dark and just on motherboards overall, there aren't that many software, or pretty much at all, for this board to accurately measure the actual Vcore value. So if we look at CPU-Z, it's pretty much reading a value that is all over the place. So it's trying to read the CPU VID, but it doesn't really measure that accurately, as the actual VID was 0.97. Now it's trying to read something, but it always stays at this value even when I'm running on LN2 and at very high real Vcore value. So we can see that the CPU is at 5 GHz, 4.5 cache, 4133 MEMS, beta BIOS from April. So the best software to measure the actual Vcore value on the Dark is the EVGA's own Elite tuning utility. So in the monitoring tab, we can now read CPU Vcore value of 1.296 to 1.299. So it's already much closer to the set value of 1.3 volts than this CPU-Z value that is jumping all over the place from 1.24 to 1.275. And now if we look at the actual multimeter, we can see that the value at idle is 1.294. So it's pretty spot on, or pretty close to the set value of 1.3 volts. And now, if we open any load, so it just any like multi-threaded load, so Cinebench will do just for this test, there is no difference between AVX and non-AVX now with fixed Vcore option in the BIOS. So if we start this test, when looking at Elite, the measured value now went to 1.29 from 1.299. CPU still all over the place, and the multimeter is reading 1.282. So there is like a 14 millivolt drop from the idle value and like 18 millivolts less than the value we set in the BIOS. So there is definitely some Vdroop from the set value. So now you understand the overall meaning and importance of load line calibration. So it's not very beneficial to increase the set Vcore value in the BIOS to stupid levels if the actual value is much lower that we want to have when we need the voltage value and the overall stability the most. So it's stupid to set, let's say, Vcore to 1.4 volts if the actual value under load is 1.28. So in that case we would always run just stupid high voltage at idle when there's no stress on the CPU and way too low value in situations when there's a load on the CPU when we need the stability the most, when the CPU is being stressed a lot. So now we can pretty much, I will just mark these results down and we can pretty much just go to the BIOS and test a different value. And I will test all the different settings for you and just wrap them up at the end. So, but anyways, even the auto value on this board is pretty good. So the load line calibration levels really differ a lot on different motherboard manufacturers and models. There are motherboard models out there from some manufacturers that, well, they have adequate voltage compensation, but then with many options they overshoot a lot. So we don't want much droop, but we also don't want too much overshoot. So if we set a Vcore value of 1.3, we want the actual value to be as close as possible to that 1.3 value, or maybe slightly above that under load, but we don't want huge overshoot. So if we have 1.3 set, we don't want, let's say, 1.38 or 1.4 under load. So that's why I often test these values with boards that don't seem to have very good software measurement. So now if we set the Vdroop value from auto to, let's say, default, so we can test that is the auto same as default. If we look at the options right here, we can see that the options range from auto or plus 90% all the way to minus 75% and disabled. So these settings pretty much mean that plus 90% max Vdroop would be the lowest setting you can set. So with plus 90% you would have the highest possible voltage drop. So I'm not even sure how bad this option is, as I never tested that one. With minus 75 and with disabled, you would pretty much have the most overshoot from the set value. So it's very possible that these two values really overshoot the Vcore a lot from the set value. So let's now test the default option and see if it's exactly the same as the auto rule. So now with the load line calibration at default, we can pretty much see that the measured Vcore by Elite is pretty much the same as before. Same goes for CPU-C, but well, it's still reading the value all over the place, so it cannot be trusted at all. And multimeter is reading, yeah, exactly the same value, so 1.294. And under load is pretty much the same. So yeah, we can conclude that the auto rule is same as the middle option or the default option in the BIOS. So it's already quite good. So that is not that bad end result at all. So you could even just use that just like that. That is not a bad voltage drop at all. So it already shows that how good the load line on the EVGA motherboard is, even at the auto rules. So yeah, I just marked that down. So let's go to the BIOS again. It will be very interesting to test the worst options, so like the plus 90%, and see how bad they are. I never tested them. I only tested these once when I originally got this board, or the engineering sample version of this board, like almost 1 year ago. So now The value that or the option that I use the most, and it's also included in all of my profiles, is the minus 50% small Vdroop option. So in my testing in general, it has been the best, so it is a little bit above the set value and the load. So with the minus 50%, you don't have voltage drop, but you also don't have too much overshoot either. So let's see how the end result looks like with the option that I would choose. So now I'm in the OS with the minus 50% small Vdroop option, and now if we look at Elite, we can see that the Vcore value is being read at 1.305. So now it's a little bit different than before, and CPU-D is still reading all over the place, so it hasn't changed even a bit. And if we look at multimeter, it's measuring 1.301. So you could almost say that that is a spot bang on the same as the set value. And let's open or let's start Cinebench right now. First check Elite 1.337 to 1.34, 1.332 on the multimeter. So yeah, it does have a bit of overshoot right now, but it's not too bad. So like 30 millivolts of overshoot, that is not that much, to be honest. So that is quite good, but you wouldn't want to have any more than that, if you ask me. So that was the best option that I usually ran. So now I think we could test the worst option and see how bad that is. Yeah, I didn't test the minus 75 and the disabled, but they would very likely overshoot even more than this. Alright, so this is the first time ever that I have booted the system to operating system with the worst possible or the lowest load-line calibration setting. And if we already look at Elite, it's measuring the Vcore at 1.284 or 1.287, and multimeter is reading 1.280 or 1.281. So that's already 20 millivolts under the set value, even without any load on the CPU. So if we start Cinebench again, we look at Elite first, it's reading 1.201, and multimeter is reading 1.196, so that is definitely a lot of voltage drop. So this is nowhere near like acceptable for overclocking situations. So that is like 85 millivolts of Vdroop from the idle value, and a bit over 100 millivolts from the set value in the BIOS. So that is definitely not acceptable for overclocking purposes. But luckily the EVGA auto values are already quite good, so it is nowhere near that bad, even when the whole setting is just left at auto. But yeah, so I cannot recommend the plus 90% value to anyone if you want to overclock your CPU. But even at 1.196, the CPU passed 5 GHz very happily. So yeah, I'm quite happy with this CPU, although it has some weird behavior sometimes. But let's check one thing again. So yeah, as we saw, the multimeter and Elite values at plus 90% option, it's still reading CPU-Z is still reading the Vcore value all over the place. So yeah, we can pretty much conclude that you cannot fully trust the CPU-Z reading on any Vcore board, and when it comes to the EVGA Z390 Dark, you cannot trust that value at all. So even when I'm on LN2 and I run the Vcore values at like 1.75, it's still reading these exactly the same VID values. So that is just not good. So it cannot run. So it cannot measure the actual Vcore at all. So it is just trying to measure the initial VID of the CPU, but it doesn't even measure that well at all. So now I will run all the different settings, and then I will just show them to you in a graph at the end of this video. And also there is another way to measure the Vcore very accurately on the Z390 Dark as well as on the X299 Dark. So you can use the onboard debug LED monitoring thingy to measure the actual Vcore very accurately. So you just have to go to the Advanced tab in the BIOS and go to the hardware monitor configuration. Check that and choose debug port orientation as normal and debug port display as CPU Vcore. That's the only thing you need. F10. And now we just have to wait that the post thingy ends. I'll just wait for the system to get to the desktop first, because there is some load during the boot process. So now I'm sitting at idle on the desktop and it's measuring 1.302 to 1.305, more at 1.305, and real multimeter is measuring at 1.301 to 1.302, so it's quite close. And I'll just turn on Cinebench again at same settings. So multimeter is measuring 1.331 with -50%, and the onboard debug LED is measuring 1.340. So I think the onboard one is getting the same information as the EVGA's own Elite software. So this is already very good. So if you have the board set up in a case, if you have clear visibility to the debug LED part of the board, then you could use that as your real multimeter to measure the Vcore at the hardware level. So just saying this as a tip for you guys. Alright, so when looking at the graphs, so the list is pretty huge, but so when looking at the let's say the worst results at the both ends, so let's start with the biggest drop, which happened with the +90% max Vdroop option. There the voltage measure at idle was 1.281, and the value set under load was 1.196. So that is a huge difference to the set Vcore value of 1.3. So the in all of the tests, the value measured at idle didn't differ that dramatically to the set Vcore value of 1.3. But when looking at this +90% max Vdroop option, the value even at idle already differed like around 20 millivolts, and the value under load differed 85 millivolts compared to the value measured at idle, and 104 millivolts compared to the set Vcore value of 1.3. Then looking at the other end of the whole graph, so with the highest load line calibration option was the disabled option, which means just disabled Vdroop, aka the max load line calibration option. There the measured value was already 1.308 at idle, so a little bit above the set value at idle, but 1.388 under load. So that is way too much voltage, so that is huge overshoot, so we don't want this either. So here the difference was 80 millivolts compared to the idle value, and 88 millivolts over the set value of 1.3. So the both ends of this graph aren't really good options. So when looking at this whole graph, even the auto or the default value, that's already quite good. So the Dark is very good out of the box in terms of voltage compensation for load scenarios. But the the best end result value was actually with the -25% Vdroop option. So I have to correct myself a bit. So the -25 is even better than the -50% one. So with -25%, the value at idle was pretty much spot on with the set value of 1.3 in the BIOS, which read at 1.299, and the value on the load was 1.313. So it's 13 to 14 millivolts over the set value in the BIOS and the set value or the measured value at idle. So that is really nice result. And even the -50% option is very good. So that's the one I have had in my profiles, and that's one of the options I have recommended people to use. So that is also pretty much spot on, measured at idle, but 30 millivolts over the set value under load. So that is pretty much the same as level 6 for latest Asus Maximus series boards. So the when I talk about the Asus boards, the level 5 is a little bit under the set value, and level 6 overshoots the Vcore by like from +20 to +40 millivolts. So the -50% is pretty much the same as the Asus level 6. So but if I have to conclude anything about this result, I would just choose the -25% option. So yeah, there's that. So that's the overall conclusion about my test. So the best like dictionary translation for load line calibration is just a voltage compensation for voltage drops under load. So if you are more interested about this topic, Buildzoid from Actually Hardcore Overclocking made a very in-depth video about this whole thing for the Gamers Nexus channel like 2 years ago. There he really explains all these terms very in depth, and he shows all the examples with numbers. So you should really go check that out if you are very interested in the theory behind this whole thing. But yeah, so other than that, so the list is quite huge. So if you ask me, EVGA has a bit too many options for the Z390 Dark in the BIOS. So it's quite clear what the end user wants from the load line calibration option. So especially for me, the load line calibration is pretty much like on or off thingy. Like with many very like old motherboards, like for example Asus Rampage Extreme from 775 platform, there the load line calibration is pretty much on or off thingy. So it's set at off by default, but you can turn it on in the BIOS. So if there's any voltage drop by default, the only thing you want as an end user from the load line calibration is to compensate that drop to get exactly the same value under load what you set in the BIOS. So we don't need this many options. So the the worst, or like the both the +90% and the disabled options are pretty much useless what you can set in the BIOS. So the options could be like off, so +90%, and on, which would be the the -25% option or the -50% option. So yeah, so we don't need this many options. Yes, one could want to fine-tune the voltage under load a little bit, but I think in just my personal opinion, we don't need this many options in the BIOS when it comes to load line calibration. But yeah, so the overall conclusion is that the Dark is very good out of the box. The default values are really great. They don't differ that much from the value that is set in the BIOS. Of course, I haven't tested these when the voltage mode is in adaptive mode, but yeah, so that's pretty much it. So if you like this video, if you have more interest towards this topic, then go check the video out from Buildzoid. But other than that, thanks for watching once again. So like and subscribe, and I'll see you on the next one.